Okay, so let me just tell you, before we even begin, I always feel like apologizing for a couple of examples. There are two ways to get the answers to these types of problems involving the normal distribution. One is by, well, there are really three ways. The often taught is you take the numbers, you transform them to a z-score, and then you look at the z-score on a table or some kind of calculator, and you get your probability answer. Long time ago, before people had calculators and, like 30, 40 years ago, even more, people used to have like a rule of thumb that if the data is within one standard deviation, then that contains 68% of the data. If it's two standard deviations, it's 95%. That's called that 68, 95, 99 rule that you see on top. So in a way, that rule, while I was taught that when I went to school, is really irrelevant today because we have this more exact method, which is easy to get on a calculator. You don't even need that shortcut. Okay. So having said that,
So
no, let me say, having said that, I still picked that example as part of the homework. I hope it's not on the test, but maybe part of the homework. And therefore, we have to do it. In other words, I really should take it out, but it's there. So having said that, to do it is not a big deal. You can even do it in StatCrunch, I believe. Um, um,
yeah, that was what I was gonna ask, if I should use StatCrunch or a calculator.
well, I'll show you how to use StatCrunch for the more typical example. Let's try. I think you can even use StatCrunch for this because they do have in StatCrunch the 6895 built in as well. So we want everything minus 9.6 or less. So I'm going to actually working this out as we speak. I'm not even sure if it's going to work out. So let's remember the numbers. The average is 4.2. The standard deviation is 4.6. And we want everything lower than 96. So let's go. So go to StatCrunch. Okay, work. Go to Stat. Now you got to go to Calculators, and you want to go to the normal calculator. Okay. Here's where I sometimes get confused because sometimes it shows up with the what's called the 68, 95, 99 rule, and sometimes it doesn't. So let's try between, which is we went below standard. We went below 9.6. Let's start doing it anyway. Maybe it will come out. So I think this was 4.2 was this number. The standard deviation they tell you is 4.9. I don't know if that's, and we want everything below 9.6. It was really minus 9.6. That's what I believe was the problem. Let me just double check that. 2, 4, oh, 4, 2, 4, 6 and 9.6. Okay, let's go back to that. 2, 4, 6. This should have been a 4, 6. Okay. Now, I'm still waiting for that. Maybe it's an options. I don't know. Nope. There. Not here. See, if this was an example involving the more traditional problem, I think that like example 4 or 5, you would just hit compute and the answer would pop out. Now, okay, when it pops out, then this pops up. You see this thing here?
Yeah.
Okay. So it tells you, so 9.6. And okay, let's use this as an example to explain. Do you know anything about the rule at all, or should I have to explain that to you?
I know about it a little bit.
Okay, so the rule says the following, that if you take a bell-shaped curve, a bell-shaped curve is characterized by this like bell called a normal distribution, and it always has two characteristics. It has a middle value, which they have to tell you. In this case, 4.2 is right in the middle. That's the most common number. And it tells you an amount of spread. And the spread is equal to the standard deviation, which is like the space between the middle and around here. So we're moving that should be around 4.6, which is around here, okay? So if you go 4.2 minus 4.6, which is one standard deviation below the average, you end up with 0.4. If you go 4.2 plus 4.6, that comes out to 8.8. So between 4.2 and 4.8 is going to be this chunk of the diagram, which I can't really make in color. This chunk of the diagram is 68% probability. If you go out another 4.2 plus 8.8, and then plus 4.6 is 8.8, add on another 4.6, it comes out to 13.4. And likewise, if you take it back 2 standard deviations, it comes out to -5. So between -5 and 13.4, that much larger chunk is 95% of the area. Go out to 3 standard deviations, meaning you add on another 4.6, it gets you up to 18. And if you take it out minus another 4.6, it takes you to -9.6. So between 9.6 and 18 is 99.7%, which is practically the whole thing. So what's missing? How much is 100% minus 99.7%? Well, the answer is you do that with a calculator, it comes out to 0.3%, which is really, that's both sides. This piece here, the missing piece here, and the missing piece here is 0.3%. But we just want everything below 9.6, not both sides, just one side in this example. So how much is half of 0.3%? The answer is 0.15%, which if you change it to a decimal is 0.0015. So after all is said and done, the approximate answer using that box of how much is below 9.6 and knowing that it contains 99.7%, the answer is 0015. So it's very close to this. So
Yeah.
technically, if you put down 0015, you would get the right answer to the problem. So let's try that. So if you well, where'd it go? Five. Oh, they wanted it as a percentage. So it's 0.15%. So this answer would work. But if you use the exact method, you'd probably be putting in 0.13%. But this would work. Let's check it out. Okay, that's how it works. So I said it quickly, so now I'll be happy. Now I said it. Now please ask me any questions that you want me to do to explain it. You follow that? In other words, yeah. You follow
Yes.
that? By using the tick marks, you see that 9.6 is 3 tick marks away. I mean, it's plus or minus. It's 3 standard deviations.
But why was it 0.15 if the answer was 0.00134?
Okay, but between 9.6 and 18, which is plus or minus 3, this is 1 standard deviation, a second standard deviation, a third standard deviation. Remember, the standard deviation is 4.6. Here's another one. Here's another one. Between these 3 plus or minus 3 standard deviations is contained 9.7%. These are percentages of the area. So how much is outside this piece? If between here and here is 99.7, and the whole thing is 100%, 100 minus 99.7 is 0.3. Okay, that's 0.3, but that's 0.3 on both sides. So you got to chop it in half to get one side. We just want one side. So 0.3 divided by 2 is 0.15. That's why the answer is 0.15%.
Okay.
Again, the best thing is to do this with a calculator as I'm speaking. If you can't do it in your head, you take 100 minus 99.7, which comes out to 0.3, say divided by 2, and it comes out to 0.15. And since we're dealing with percentages, not decimals, the answer is 0.15%, and you put a 0.15 in there. We'll see some other examples. Maybe we'll make it easier. How much is bigger than 4.2? Well, that's easy in the sense that 4.2 is the exact middle. So 50% is on one side and 50% is on the other side. So the answer to this one got to be, without even using these tick marks, the answer just by knowing that basic property of the normal distribution, it's got to be 50%. Okay. Now they want how much is between -5 and 13.4. So again, you got to, here's where the tick marks come in handy. -5 and 13.4. Well, that's 2 standard deviations below, 1, 2. It's 2 above, and the rule says between any 2 standard deviations on a normal curve is 95%. So the answer got to be 95 there. Finally, how much is 8.8 or more? Well, 8.8 is here. Here you got to use, again, a little bit of knowledge. And here's 8.8, right?
Mm-hmm.
8.8. Now, how much is between 8.8, which is one standard deviation, and the other standard deviation? Well, again, that's the 68%. So from here to here, from here up to here, contains 68%, about 2/3 of the total area. Well, how much therefore has to be on the other side? If from here to here is 68%, how much is outside? How much is outside? How much is higher than 8.8 or lower than 0.4? What's the area outside of that? Well, you do 100 minus 68, that comes out to 32%. But that's both pieces put together. We just want one side. We want bigger than 8.8. So how much is, so the 32% divided by 2 is 16%. So by that logic, once you know your basic, how this thing works, it's got to be 16%. I'm sure if we put down 16, it's going to be right. Okay. Now, before we go further, again, this is difficult to seeing this for the first time, but that's so again, I'd be happy to repeat it or explain more details, but that's how you go about figuring this out. It turns out that the shortcut is much harder to do than the real way. The real way, you just plug these numbers in, the different numbers they're giving you, plug them in here, and well, this stays the same because the 4, 2 and given, but you just keep changing this or changing the greater to a less than sign, and the answer pops out. So it is more difficult to do it by the so-called shortcut method, using these tick marks, but we can do an example involving, the regular problem in a minute, but main thing is that you make a picture for yourself and you say, I can't do this over, make these vertical lines, make a bell-shaped curve, make the middle value 4.2, you move across here another 4.6 to come up to 8.8, and make a vertical line here and a vertical line at minus, 1 stand, and then you point, you write out, or it says this in the book, this is 68%. That means this piece out here is missing 16% on this side and the 16% on that side. So the answer to the question got to be 16%. The point is, there's no formula. It's just knowing how that table works in terms of those 3 divisions. +1 standard deviation, +2 standard deviations, +3 standard deviations.